Hello, and welcome to today's webcast, Cisco UCS, Commonly Reported Issues and Troubleshooting Methods, brought to you by Datalink. My name is Danielle Moore, Marketing Manager, and I will be your moderator. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenter. The console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. All questions will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn this presentation over to our presenter, Conrad Madewell. Conrad, the floor is yours.
Thank you very much. Thank you very much, and welcome. Today we'll be discussing UCS, or Cisco's Unified Computing System. So on our agenda today, we'll be viewing the UCS hardware and software interoperability. Cisco likes to refer to this as the matrix. We'll also be discussing commonly reported bugs, just one or two. Also, end host mode or switch mode, what to choose and why. We'll also be discussing memory alerts, which ones matter and which ones can be ignored. Protecting your UCS, how to leverage backups as insurance should problems arise. And then we'll run back over our summary. The value of the UCS hardware and software interoperability. Here's a screenshot of what they call the matrix. In order to use that particular link, you want to gather some environment information that you're going to need to know, such as your server series. Is it UCS managed server? Is it a C-series standalone server? You'll also need to know your UCS release, the version that you're currently running, or the version you are planning to use. As an example, you'll see UCS 2.2.3D or UCS 2.2 8B. And if you're using the C-series standalone, you'll see items like SIMC 2.0 or higher. You also need to know your server model. Know the model number of your server, including the CPU type. For example, you have a B200 M4 with an E5 version 3 processor. For your C-series, it'll look something like the C460 M4 with the E7 version 3 CPU. You'll want to note your operating system and version. For example, your vSphere 6.0, that would also qualify for your vCenter or ESXi host in particular. We also support Red Hat Enterprise Linux. Other examples would be Windows Server 2012 R2. You have Oracle VM. You also want to know what adapter you have installed on each of those servers. Below is an example of the product ID and what it equates to. So when you see the MLOM 40G-01, you'll know that that's a 1240. You see a -03, that would equate to a 1340 VIC. Underneath it, you'll see what the C-series looks like. Most popular is the 1227s and the 1225s. So now that you've gathered your environmental information, you want to go ahead and proceed in using the matrix. After accessing that link, you'll come to this particular page, and you'll notice you'll have little drop-downs. Your server series, and in that order, you'll start to kind of drop down to those supported environments or components of the configuration. After you're done, you want to find that chosen one. Now that this is all spit out to you, and you've dropped down all your selections, you'll have that little text box at the bottom that gives you a lot of information. So what does this really mean to you? This tells you your supported drivers. Your ethnic version must be at this level to be considered as supported. You don't want to go below, you don't want to go above. Same thing for your ENIG version. Both of these can actually disqualify us from having advanced technical support or accessing the business unit or working with the developers in order to troubleshoot some very serious or high-level issues. Then you want to compare it to what drivers you are currently using to determine whether or not you're supported. As an example, you have Windows, you have Red Hat Enterprise Linux, you have VMware, vSphere, ESXi, and the appropriate commands and captures as to how to obtain this information. Once again, this is for each server. Moving along now, we have commonly reported bugs. Now, a lot of you have probably seen this little guy. This is a known Cisco bug. It's an old one, but it does come back after it's fixed in one version. You might see it in a later release, and then they'll have to readdress that and release yet another version. This one here, it does not show that the identity can be established. Basically, the FRU number needs to be referenced to something, and it has nothing to reference to. So you're going to see these in your fault summary. They are considered minor, and they actually have no effect on the performance as to what's been seen so far. You address that by simply, as you can see in the GUI, by going to the correct equipment in your navigation pane. You can drill down in the viewing pane to get to your firmware management. So you would go to equipment and then firmware management. And then as you can see there, you're going to go to catalog package. And you want to check it to see if you have a catalog version actually being posted. A lot of times this will be blank or outdated, so you'll see those kind of dim invalid FRU errors. So when you notice that due to that incompatible catalog load, because basically it doesn't have a point of reference, and either it's not there at all, or the catalog just doesn't support it or have any awareness of that FRU. So basically, this is the step-by-step instructions of what you just saw in the screenshot. Once again, you're downloading that catalog bin from the Cisco site, being the first step, really, and you're going to download it into the UCSM, much like you would the firmware or possibly a debug file. And continue to follow the instructions going through the firmware management and catalog package. And, of course, you can always change your catalog package version under those actions. And we can click back here to show you exactly what we're talking about right there. And, of course, when it's all done, you're going to want to reset all your I/O modules from each chassis to affect the new catalog version. You might want to do this strategically because considering you have two paths, you might want to reset all your IOMs on your subordinate path, do a failover, and reset the other IOMs to avoid any kind of impact to your environment. Here's another popular one that many folks may actually see this in their fault summary. It will not be seen in the fault summary, but when you actually log in to the CLI and check your show faults detail, this may be one of the problems. You can also prove that it's actually affecting your environment by simply logging into the CLI and using the show cluster state command. The results at the bottom will let you know that, for example, Fabric B is seeing chassis CPROM local I/O failures. It will help you localize to which chassis, and it does warn you that switchover may interfere with switchover progress. So this is actually a serious problem for a lot of our customers. And here is your wonderful solution or workaround once you kind of see this. Now, as I put it there, the issue can clear on its own eventually. I've only seen that once. Most of the time, our folks will just go ahead and reseat the fan modules, the PSUs, and the IOMs. Re-acknowledging or power cycling the chassis has been done by many of my customers for some reason, but I would try to steer away from there, considering that you will be impacting a lot of production possibly. Here's a popular bug, and this is actually related to the last bug that you saw, advising of critical thermal problems. You will see that kind of log entry possibly identify that it is a critical issue and then clear on its own and just keep toggling back and forth. So when you see this issue may indicate an I2C congestion problem. The I2C bus handles all the internal communication for UCS and may become congested to a point where the sensor readings are missed due to timeouts. Cisco considers this to be a cosmetic issue, which can be seen affecting the PSUs, fans, dim temperature readings, and IOM status. The log entries can also get filled so that it makes it quite difficult to investigate issues when you're looking for specific errors. Administrators may receive alerts in the middle of the night that range from 1 or 2 alerts to over 500 within a 6-hour period. This issue can also cause the fans to increase in speed since UCS is not processing the readings. Customer may report that their chassis sounds like an F-16 taking off. The solution, of course, is to update to a fixed version of UCS firmware as the long term, but in the meantime, you can consider them as to be quote-unquote cosmetic. Okay, so we're going to move on to the importance of reviewing field notices. So what's a field notice? Well, the field notices are notifications that are published for significant issues other than security, vulnerability related issues that is handled by PCERT that are directly involved with Cisco products and typically require an upgrade, workaround, or other customer action. Field notices are posted to Cisco.com. So who's sending them? Well, you're going to have to actually register and modify that ability in the Cisco notification service, and I have provided the link there. And who do they go to? Anyone that has that account and can add that notification for field notices, software advisories, end of sale or support, known bugs, and software updates. They can set it up for RSS feed and email, and it's completely customizable for your awareness. End host mode or switch mode. What to choose and why. This is a big subject a lot of our customers want to talk about. So I thought it'd be a good idea to throw as much of that information in here as possible. So let's talk about Ethernet end host mode. This is the default mode of operation. Any changes to the operating mode will require a reboot of the fabric interconnects. So what are the features? Well, there is MAC learning for servers in the chassis only. It will not learn MAC addresses from the upstream LAN or network ports. The server VNIC is pinned to an uplink port or port channel. This is what end-host forwarding is completely based on. Now, there is no spanning tree protocol on the uplink ports or server ports. And UCS connects to the LAN much like a server rather than a switch. It prevents loops by preventing uplink to uplink switching. It's blocked by hardware, which is why spanning tree is not being used. And it supports upstream virtual port channels. It's also transparent to the upstream LAN. The external LAN sees the UCS fabric interconnect as an end host with multiple adapters rather than the elaborate setup that you normally see. It performs local switching for all the servers on the same VLAN like any layer 2 switch. And the network to server unicast traffic is forwarded to server only if it arrives on the pinned uplink port. This is the reverse path forwarding or RFP check. So packets with the source MAC address of a server received on an uplink port will be dropped, and that is going to be known as your deja vu check. Let's talk a little bit more about end host mode. Particularly in multicast forwarding, your benefits or features is broadcast and multicast packets are pinned to exactly one uplink port or port channel. The Fabric Interconnect will actually automatically pick one uplink port as the broadcast listener and multicast listener for all your VLANs. Any broadcast or multicast packets will be forwarded down to the servers. Any broadcast or multicast packets received on any other uplink will be dropped. And all your multicast groups are pinned to the same uplink port. And like unicast, server-to-server multicast is locally switched. The Fabric Interconnects performs the RPF and the deja vu checks as it does for unicast. So it's going to definitely use that source MAC address to determine where the source was, and if it knows that, okay, you're coming in the wrong port, I'm going to go ahead and discard these packets. So moving on to switch mode, this is a little bit different. This will make the Fabric Interconnect act like a traditional switch with support for spanning tree on the uplink ports per VLAN as defined by the Cisco per VLAN spanning tree plus protocol. Configuration of spanning tree parameters, the bridge priority, hello timers, etc. is not supported. The VLAN trunk protocol is also not supported, so you will not be able to use VTP in this situation. MAC learning is actually going to be performed on the server and the uplink ports, whereas the end-host mode, it only performed MAC learning on just the server, which is why you don't see the entire network going upstream. And, of course, upstream links are blocked according to the spanning tree rules. So when do you use switch or end-host mode? Well, in most cases, end-host mode is preferable because it offers scalability and simplicity for your server administrators when connecting to an upstream network. However, there are other factors to consider when selecting the appropriate switching mode, including your scalability, the efficient use of bandwidth, fabric failover, active-active link utilization, disjoint layer 2 domains or loop-free technology, optimal network behavior for the existing network topology, and your application-specific requirements. Talk a little bit further into each one of those. We have scalability. So without spanning tree running, end-host mode provides the most scalability because the control plane is not occupied. Additionally, because there is no MAC address learning on the uplink ports, The MAC address table can scale to support as many virtual machines as the number of entries available in the MAC address forwarding table. So for scalability, the recommended Ethernet switching mode is end host mode. One of your concerns is efficient bandwidth use. So using static pin groups in end host mode, an administrator can explicitly define the upstream port for a particular VNIC. This approach provides control over bandwidth and determining the behavior for a VNIC. For this pain point, the recommended Ethernet switching mode is end host mode. Let's talk about fabric failover. Is this one of your main concerns? Cisco UCS fabric failover, depending on the status of the uplink ports, is available only in end host mode. In switch mode, OS-based teaming, active passive software, is required to provide the failover. The pinning feature provides the association between the uplink port and the VNIC that is used for tracking and for providing the failover. So for a fabric failover, the recommended Ethernet switching mode is also end host mode. Now, we have active link utilization. So without the use of technologies such as your virtual port channel or VSS upstream, switch mode blocks ports that depend on spanning tree route selection. By using pin groups in end host mode, effective upstream bandwidth utilization is actually possible. Now, pinning is only applicable in end host mode. So, for active links without a virtual private port channel or VSS upstream, we recommend end host mode. When you have virtual private port channel or VSS available upstream, end host mode or switch mode can be used. And of course, it does support forwarding paths with VSS or VPCs upstream. Another pain point for customers is optimal network behavior for the network topology. In some commonly deployed LAN topologies, switch mode provides the best network behavior. A typical example is a switch directly connected to a pair of HSRP routers. That's your hot standby router protocol, routers that are the spanning tree protocol routes on different VLANs. Switch mode provides the optimal path because of the use of spanning tree protocol. For example, a VNIC belonging to an odd-numbered VLAN can be dynamically pinned to link X on Fabric Interconnect A. So as a result of this process, traffic traverses an extra hop, which is the inner switch link, the ISL, to the HSRP master. And of course, you got your VLANs load balanced across a pair of switches. Here's a little topology real quick. So when a switch is directly connected to a pair of HSRP routers, the recommended Ethernet switching mode would be actually switch mode because it provides the optimal path. And host mode can be used if static pinning is employed. And then you have your application-specific requirements, whereas certain applications such as Microsoft Network load balancing in unicast mode require unknown unicast flooding to operate. And in end-host mode, unknown unicast broadcasts are not flooded, so you would have to use switch mode. In applications that require load balancing in unicast mode, the recommended Ethernet switching mode is going to be that switch mode. Memory alerts. Which ones matter and which ones can be ignored? So we have our hard versus soft errors, the two types. Errors that are caused by a persistent physical defect are traditionally referred to as a hard error. A hard error may be caused by an assembly defect, such as a solder bridge or a cracked solder joint, or may be the result of a defect in the memory chip itself. Rewriting the memory location and retrying the read access will not eliminate a hard error. This error will continue to repeat. Errors caused by a brief electrical disturbance, either inside the DRAM chip or an external interface, are referred to as a soft error. Soft errors are transient and do not continue to repeat. If the soft error was the result of a disturbance during the read operation, then simply retrying that read may yield the correct data. If the soft error was caused by a disturbance that upset the contents of the memory array, then rewriting the memory location will also correct that error. Now, hard errors are typically detected by memory tests run by the Cisco UCS BIOS at boot time, and any modules containing hard errors are mapped out so that they cannot cause errors during the runtime. Cisco UCS servers employ memory patrol scrubbing to automatically detect and correct the soft errors during runtime. So what does that come down to? This is what we see in our GUI. You have your correctable versus uncorrectable. Correctable leading to your soft errors, and your uncorrectable leading to your harder errors. So the soft errors, obviously we can use some minor customer action to try to address those issues. And then those uncorrectables is basically hardware replacement at that point. So whether a particular error is correctable or uncorrectable, it depends on the strength of the ECC code employed in the memory system. Dedicated hardware is able to fix correctable errors when they occur with no impact on the program processing. Uncorrectable errors generally cannot be fixed and may make it impossible for the application or the OS to continue processing. There is no correlation between correctable and uncorrectable errors. With this being stated, replacing a module with correctable errors in order to avoid uncorrectable errors may just create unnecessary server interruptions, which will not reduce the risk that an uncorrectable error will occur. So basically, a lot of customers feel that when they see these correctable errors increment, they want to go ahead and rush to replace it before the uncorrectable errors are seen. And several studies and tests have proven that there's actually no connection between the two. Customers who experience a degraded memory alert for correctable errors should upgrade to that latest UCSM or the or SIMC for the rack standalone mode. If the customer does not wish to upgrade, then you can simply reset the memory error and resume the operation. Let's see if we go ahead and take a look at what we're talking about here. So when you look at the correctable or soft errors, you want to go ahead and reset those counters or those errors by accessing it using the UCSM. So once you get into the GUI, navigate to the memory slot that is referenced in the fault, and then and as you can see here, you simply click Reset Memory Errors. Now, the GUI sometimes is not friendly to all, and others feel that the CLI is just a lot easier. You can simply access and scope your server and reset all memory errors and make sure that you see your asterisk there to know that a change has been proposed, and you can go ahead and commit that to the buffer. As well as you can see here, we added some more scripts, especially here on the C series at the bottom, where you can easily follow the same concept to reset them through the CLI. Most folks go through the GUI just because of the simplicity of it, and they can also confirm if the errors have cleared from the fault summary. All right, so we're going to go ahead and go into protecting your UCS system. We want to talk about a little bit about backup and export configurations. When you perform a backup through Cisco UCS Manager, you take a snapshot of all or part of the system configuration and export that file to a location on your network. You cannot use Cisco UCS Manager to back up the data on the servers. You can perform a backup while the system is up and running. The backup operation only saves information from the management plane, and it does not have any impact on the server or the network traffic, so you can actually run this through your peak production hours, and there should be no impact. Also, I did not include it in there, but you will notice that this is actually among the first few steps of the update of the firmware. So when you look at your FSM tab and monitor the progress of the update of the firmware, you'll notice that UCS will automatically back up your system. However, we also encourage you to go ahead and back up your information manually as well. So here are the backup types, and to explain further, you have your full state, which is your binary file that includes a snapshot of the entire system. And you can use the file generated from this backup to restore the system during your disaster recovery. This file can restore or rebuild the configuration on the original fabric interconnect or recreate the configuration on a different fabric interconnect. You cannot use this file for an import. You have an all configuration backup, which is your XML file that includes all system and logical configuration settings. You can use the file generated from this backup to import these configuration settings to the original fabric interconnect or, again, to a different fabric interconnect. You cannot use this file for a system restore. We have system configuration, it is also an XML file that includes all the system configuration settings such as usernames, roles, and locales. You can use the file generated from this backup to import these configuration settings to the original fabric interconnect or to a different fabric interconnect. You cannot use this file for a system restore. And then we have logical configuration, also an XML file that includes all logical configuration settings such as your service profiles, your VLANs, your vSANs, your pools, and policies. You can use the file generated from this backup to import these configuration settings to the original FI or, again, to a different FI. You cannot use this file for a system restore, unfortunately. Now, as far as the considerations and the recommendations for backup operations, before you create a backup operation, we want to consider the following things. Your location. The backup location is the destination or a folder on the network where you want the Cisco UCS Manager to export the backup file. You can maintain only one backup operation for each location where you plan to save a backup file. Another consideration is potential to overwrite backup files. If you rerun a backup operation without changing the file name, Cisco UCS Manager overwrites the existing file on the server. So to avoid overwriting existing backup files, change the file name in the backup operation or copy the existing file simply to another location. And another consideration is multiple types of backup. You can run and export more than one type of backup to the same location. You need to change the backup type before you rerun the backup operation now. So we recommend that you change the file name for easier identification of the backup type and to avoid overwriting the existing backup file. A few more here. Scheduled backups. You cannot schedule a backup operation. You can, however, create a backup operation in advance and leave the admin state disabled until you're ready to run the backup. Cisco UCS Manager does not run the backup operation, save, or export to configuration file until you set the admin state of the backup operation back to enabled. You have your incremental backups. You cannot perform incremental backups of the UCS Manager system configuration. We want to talk about backwards compatibility. Well, starting with the release 1.1 of the UCSM, the full state backups are encrypted so that the passwords and other sensitive information are not exported as clear text. As a result, full state backups made from release 1.1 or later cannot be restored to a Cisco UCS instance running on earlier software releases. So that basically that is your cutoff point there. So basically, to summarize, one of the biggest critical things is you want to check the matrix. Make sure you are supported. In those drop-downs that you'll see on that site, not only will it tell you what drivers you are required to use, it will also give you a good idea as to what versions of the operating system that you might be planning to use in the future. Is it going to be supported? Is it supported now? You will see that sometimes it'll get cut off with ESXi 6.0 Update 2, and anything, if they do release an Update 3, until it's actually part of the matrix, it will not be supported, simply meaning Cisco does not tell you what to do with your UCS system, but if you do want their assistance and their help or chase down a bug or investigate, you're going to make sure that you will be in full compliance of that required configuration that's going to be dictated on that site. We went over our common bugs, our DIMMs, our CPROMs, our thermal problems, a lot of them, most of them being a code issue in regards to the I2C bus. They have resolved a lot of those issues, such as for example, the thermal problem. The window for the timeout was just too narrow, so in 223D, they expanded that window so the timeout will not occur as often, and it greatly impacted those 800 or 500 emails that some poor administrator was receiving while they were trying to get a good night's rest. Went over our end host mode versus our switch mode, how to choose and what considerations to think about. We also talked about our memory alerts, which has been a big issue as far as correctable versus uncorrectable. And the Cisco stance on that, unless you get very lucky, is they do not replace correctable errors. They don't replace the DIMMs because of them. They'll have to prove the hardware failure. So you will see a lot of recommendations in regards to resetting the memory errors, maybe going as far as resetting the SIMC, maybe even going as far as scheduling a maintenance window and re-acknowledging the actual server. You can just imagine how many different workarounds and plans moving forward that will be provided to avoid having to replace the hardware with more hardware and probably continue to see correctable errors. And of course, your backups. Ensure your UCS environment and save a lot of your disaster recovery time by just setting that up and making sure the location is correct and following the strategies of the file name change unless you don't mind the override. And thank you very much. I really appreciate your time.
Thank you for attending today's webcast. An on-demand version will be available within 2 to 3 days, and you will receive an email notification once the recording is available. Thank you again for participating.